Hello, I am Mohammad Rashid Ansari from Alma Better Cohort Oracle. In this video, I am going to discuss 5 questions out of 20 questions of Capstone Project 1, which is given by Alma Better. So, those 5 questions are: question 1 from code bug fixing, question 2 from improvised perspective to the coding problem, and the remaining 3 questions are from logic building and coding questions. So let's get started. First question is calculate BMI. Question is, a couple of issues are present in provided code. Identify and rectify these errors to ensure the code function properly. So in line number 5, so basically in this code we have to find errors. So in line number 5, function calculate BMI, weight and height. Weight is in kg, height is in meter, and this is the formula. Line number 7 is the formula of calculating BMI, body mass index. Now in line number 9, if BMI is less than 18.5, it will return underweight. Okay. In line number 11, else if BMI greater than equal to 18.5 or BMI less than 24.9, it will return normal weight. So in this line there is an error. What is the error? Here if we take BMI, the value of BMI less than 24.9 and the same value is also less than 18.5, so in both the case, in both the condition, it will return you normal weight, which is incorrect. So for instead of here or operator, we have to use AND operator. So with the use of AND operator, so it will return normal weight when the value of BMI is lie in between 18.5 and 24.9. So in that case it will return normal weight, and the same error is in the line number 13 also. Instead of OR operator, we have to use AND operator. So here I have written the code, the correct solution. I have used in line number 30 and line number 32. Instead of OR operator, I have used AND operator. And one corner case I have used in 23, line number 23. Here I have given a condition: if weight is less than equal to 0 or height is less than equal to 0. That means if weight and height will be less than or equal to 0, it will return you a string. Weight and height must be positive. So you have to mention both weight and height positive. So if we talk about time complexity in this code, time complexity, the code contains simple conditional checks and do not depend on the input side. So the time complexity is constant. And if we talk about space complexity is also constant, since the code's runtime and memory usage are not affected by the input side. So the time complexity is so the space complexity is constant. So let's move to the next question. Find longest word. Question is, write a JavaScript function, calculate find longest word that takes a sentence string as input and determines the length of the longest word within the sentence. Rewrite the above code using for of loop. Okay, so first of all we discuss the code which is given, and then we are going to write the code using for of loop. So here in line number 9 there is function find longest word. Sentence, here sentence is a string, and here we are using sentence dot split, which converts a string into an array. Okay, array of words, we can say array of words, and here words is the array. If we see in the line number 38, the input is coding is the fun a string using sentence dot split. This string will going to be converted into array. The array of words, this coding is break down into the small strings, string of words. Now here we are considered a variable. Let max length is equals to 0, and here line number 13 there is a normal for loop. In this for loop, constant length is equal to words I dot length. That means while iterating, it will check the length which is greater than the previous one. Okay, it will keeps on checking, because in the array there are element in the form of string. Okay, so every string has their own length, so it will check the maximum length. It will, if there is any word which is the maximum length, it will update the max length. The max length is equal to the length, and at the end it will return max length. So here the solution 2. In the solution 2 we have just used for off loop instead of normal for loop, and the remain code is same. So if we talk about time complexity, so both the code has the same time complexity, the linear time complexity. Splitting the sentence into words, that means this line, splitting the sentence into words using sentence dot split takes on time, where n is the length of the input sentence and the iterate through those words. So that's why the time complexity is linear. And if we talk about space complexity of the code is, the space complexity of the code is on linear due to the words array. The space required for this array is on, where n is the number of words in the sentence. So this is space complexity. So let's move to the next question. Here. Find primes. Question is, write a JavaScript function find primes that takes a positive integer n as an integer as an input and return an array of primes number less than or equal to n. So here we start from line number 7. Function find primes n. This is a function, and we are declare a variable, declare a empty array. Let prime numbers is equals to empty array, an array we have considered. So after this, in the line number 10, this is the another function. This function is defined, function is prime. This function is defined to check whether a given number is a given number, means the number is prime or not. So for checking the number is prime, so for that reason we are using this function. And this is the part of the outer function. That means if n is less than equal to 1, return not a prime number. That means if n is, if the positive number is less than, if the n is less than or equal to 1, it will return you not a prime number. We already know that the number which is less than 1 or equal to 1, it's not a prime number. The smallest prime number is 2. And if we talk about this line 22, this is the outer loop. So from here, so we start from 2, the minimum prime number. So from 2 till the n, the positive number, the input. Okay, so here is the condition, if is prime. So the number in between, including this both 2 and n, it will check whether the number is prime or not. So for that we give this number to this is prime. Here is prime. Now so let's take an example of 2. 2 is a prime number or not. So this 2 comes in this is prime as a num. So here for loop let I equal to 2, I less than math dot square root of num. That means if a number is, we have to check whether this number is divisible by these numbers or not. Num is divisible by I. Okay, if the number is divisible by this 2 and in between the number this math dot square root of this number, the number lie in between this and including this both, if the number is divisible by this and giving reminder as 0, that means it's not a prime number. So for a prime number it should be not divisible, means its reminder should not be 0. So in that case it will return true, or it will, if it's not a prime number, it will return false. So in case of true, if the prime number, if it is a prime number, then that number will going to be pushed inside the prime numbers this, and it keeps on checking each and every number from 2 till n. Here the number is the prime number, and at the end it will return you the array of prime numbers. So if we talk about the time complexity of this code, the time complexity is n into square root of n. So why this is the time complexity? So if we talk about time complexity, so there is basically 2 loops on which it iterate from 2 to square root of n. So there is 2 square root, like line number 11, it will iterate from 2 to square root of n. Okay, so here the time complexity will become O square root of n, and here also one loop iterating from 2 to n. So here the time complexity will become On. So the overall time complexity will become O n into square root of n. And for space complexity, the space complexity is On, linear space complexity, due to prime numbers array. Let's move to the next question. Reverse string. Question is, write a JavaScript function reverse string that takes a string as an input and return the string with its character reversed. Here we have used in this code, here we have used str.split. What it will do, it will convert string into an array of characters, array of strings, and then we are using reverse. It will reverse the every string of the array. It will reverse the array, that means. And after that we are using join. That means it will concatenates every character, every strings present in the array. It will concatenates, and at the end it will return you a single string. The reverse single string. In this code, if we talk about time complexity, the dominant factor in terms of time complexity is the reverse operation. This reverse operation. So due to that, the time complexity is On. So the overall time complexity of this code will become On, linear time complexity. And space complexity of this code is also linear, mainly due to the space used for the array created by str.split, this one. So that's why space complexity is also linear. And at the end, the last question is, write a JavaScript function sign of product that takes an array of integers as input and returns sign of product of all the integers in the array. The function should return 1 if the product is positive, -1 if negative, 0 if the product is 0. So if we see in the line number 8, function sign of product nums. What is nums? Nums is array. In line number 9, we have considered a variable, let sign is equals to 1. Now in line number 10 we are using for loop. For loop, what it will do, it will iterate and check whether the no, elements of the array is 0 or not. If any element in the array there is 0, the whole product of the array, the whole product of the number in an array will become 0. So that's why we give the condition nums I. That means every element it will going to check equals to 0. If any element is 0, then the return will be, the product will be 0. And if any number which is less than 0, that means negative number, it will change the sign. Okay, so if we take the example console.log sign of product, index 0, if we see here index 0 in this array is 2, the sign will remain unchanged, the sign will remain positive. Then the index 1, the value is negative, so the sign will change, it will become negative. Then again at index 2 the value is -2, so the sign will again change, it will become positive. And at the end, at the index 3, it will remain unchanged, so the overall product will be positive, so it will return 1. Now if we talk about time complexity,